Creating a valid 3D scene in Fusion requires a minimum of 4 tools. Naturally, some sort of geometry, a camera 3D, a merge 3D, and at the end of the chain a renderer 3D, which produces a 2D image from the incoming scene. The 3D geometry could be imported from a variety of external applications or generated in Fusion, using a shape 3D, an image plane, or a particle system. The camera connects to the geometry by means of a merge 3D. This works pretty much the same as with the standard 2D merge. Finally, a renderer 3D produces a two-dimensional image for further processing. Navigating the 3D view also works the same as navigating 2D views. Middle mouse button pans the view. Left mouse button and middle mouse button zoom in and out of the view. Alt and middle mouse button rotate the view. The quad button switches the display to quad view mode if desired. The light switch activates a virtual standard light in the scene. Click on any tool to display its 3D widget and move it around. Q, W, and E, or the associated buttons in the upper left of the view, toggle between translation, rotation, and scale respectively. Switch to the 3D Controls tab of any 3D tool to enter those values numerically or to set up expressions. As with other Fusion tools, little dots show the default position of any value. Click on those dots to reset the control to its default value. Naturally, all these controls are animatable as well. Right-click in an empty area of the 3D view for a context menu. Right-click in the lower right corner for a menu to switch the viewpoint to any existing camera or back to perspective. The same menu can be used to copy the current point of view, for example from the perspective view, to the camera. In the renderer 3D, switch on lighting if desired. Keep in mind though that the virtual default light does not produce renderable illumination. In order to render any lighting, a real light needs to be added to the scene. By default, the renderer is set to software mode, which works on all computers. On contemporary machines with OpenGL-compatible graphic cards, the OpenGL renderer can be used as well. In most cases, the OpenGL renderer is many times faster than software, and also offers sophisticated controls for supersampling and depth of field.